It seems like most people are in here. A couple people are still probably trying to get in. They're still responding to on campus. That's okay. Um, if you haven't done that, please do that as soon as you can. Um, Couple things I want to do today. I realized people were having trouble, a little bit of trouble with the R1 IXL. That's okay. Um, I wanted to review a couple of things that will help you get that finished. Okay, so what I have up on screen is kind of what we did last class. That's all the right triangle stuff. So SOHCAHTOA, what sine, cosine, and tangent actually are, as well as a triangle to kind of help you figure out which sides are what. Okay. There are two other things that are kind of required to finish this IXL, and both of which we've gone over before. All right. So the first one is just the Pythagorean theorem. And what that says is that if you have a right triangle, which is pretty much the only thing we're going to be dealing with for the next like couple weeks, all right? So the first thing that we have to have is just a right triangle, all right? Pythagorean theorem says that the longest side, the hypotenuse, and if we have this angle theta here, we'll call this side the adjacent, and this side the opposite. If we have this triangle with those sides labeled, we can say that the opposite squared plus the adjacent squared is equal to the hypotenuse squared. Okay, so given any two legs of a triangle, you should be able to find the third. All right, and that was kind of a major part of this IXL, you being able to do that. And we did go over that. Am I expecting to do it perfectly right now? No, but we did do it. We have covered it. And the other thing is just radicals and dealing with them. All right, in radicals, the thing that we need to know, there are two things that we need to know. We need to know how to simplify them. So for example, if I have the square root of 12, our radical rule, the only thing that we've gone over with radicals is to say that we can rewrite radicals as radicals of factors of that number. All right. So we can rewrite the square root of 12 as the square root of 4 times the square root of 3. So what I normally do is I just make kind of a factor tree. All right. So factors of 12, there's a couple of them. There's 1 and 12, 2 and 6, and 3 and 4. And obviously we can switch those around. It can be 4 and 3, 6 and 2, 12 and 1. But given these pairs of factors, we're trying to look for a pair with a perfect square factor, or with a perfect square. Okay, so one kind of is a perfect square, but we don't really consider it. It's just 1 times 1 is 1. All right, but 12, there's nothing times itself that equals 12. Okay, so that's kind of off our list. 2, there's nothing times itself that's equal to 2. And same with 6, there's nothing times itself that's equal to 6. So that's off our list. And the only other option we have is 3 and 4. Okay, so there's nothing times itself that's equal to 3, but 2 times 2 is 4. So 4 is a perfect square. So we need to use this pair of factors, and we can rewrite that like up here. All right, then we just simplify. So the square root of 4 we know is 2. And then the square root of 3 we can't simplify anymore. So we get 2 square root of 3. All right, and that's as simple as that can get. Obviously, they get harder than that, but that's really what we're dealing with. We're trying to factor out things that are perfect squares, and then we simplify from that. The other thing with radicals that we need to know is rationalizing radicals, or rationalizing fractions. right? So if we have a fraction, say we do a bunch of work and we end up getting something that looks like 3 over square root of 5. Okay, and you've done all the correct work, you've gotten all the sides, you plugged it into the right ratio, and that's kind of like your final answer. That is not an appropriate final answer, but it is very close. Okay, and the reason it's not a good final answer is because it has a square root in the denominator, which you cannot have. Okay, so in order to rationalize this, you need to multiply by this clever form of 1, which cancels out the square root in the denominator. Okay, so whenever you see two square roots doubling, so like the square root of 5 times the square root of 5, that's just equal to the thing inside the square root. Okay, so the square root of 5 times the square root of 5 is just 5. And then we have 3 rat 5 up top. So Seamus, we'll get to that, but it's still the same rule. You cannot have a square root in the denominator. So I guess we can do that right now. So if we have a square root in the denominator and numerator, say if we have like square root of 3 over square root of 7. Okay, and you did all the work, and that's all the right numbers, that's the right ratio, and this is kind of like your final answer. All right, in order to rationalize this, we still do the same thing. You still have to multiply, or you still have to get the square root out of the denominator. Okay, so you have to multiply by this clever form of 1, and then simplify that. Okay, so the denominator is the easiest part. Square root of 7 times square root of 7, that's just 7. Okay, and then on top, we have rad 3 times rad 7. Okay, because they're both under a square root, we can multiply them together, and we get rad 21. Okay, so that would be our rational final answer. Okay, so the problem I had is where you had a radical in the Pythagorean theorem. We'll get to those. I'm going to do examples kind of every type of question that you would run into. But everything that you see on your screen are like the basic tools that you need in order to solve for them. Okay, and they're all things we've done. It's just asking you to put all of them together at once. Okay, so before we move to examples, and I realize you guys have questions and specific questions, and that's great. But before we get to those, are there any questions about what's on your screen right now? So why did the 7 stay 7 again instead of going to 49? It kind of does. So I like to, when you multiply a square root by itself, it's like square root of 3 times square root of 3, or in this case, square root of 7 times square root of 7. Those square roots just cancel each other out, and then you get 1, in this case, 7, right? So square root of 5 times square root of 5, that's just equal to 5. Square root of 19 times square root of 19, that's just equal to 19. Okay, because you're basically squaring that thing, which undoes the square root. So in this problem, and I think I'm trying to answer your question. You multiply these two square roots of 7 together, and because you have two things under the square root and they're the same, you just get what's under the square root. All right, and we'll work through this. Um, I've got quite a few examples for you. All right, so let's move on to some examples so you can actually kind of see what's happening. All right. So this that I have up on the screen now, that is number 8 on that second worksheet in on campus. All right, so that this isn't for homework or anything. This is just a bank of questions. This is the second one in the new topic. All right, and it's asking, so given this figure ABC with side lengths 16 and 20 and that angle theta given, we want to find the tangent of theta. All right, so the first thing that I want to do is to just label what we have. All right, and because this angle up here, this A, because that's the right angle, we know that this side must be the hypotenuse. All right, so 20 is the hypotenuse. The side attached to theta, that's the adjacent side, or the side that's attached to theta that's not the hypotenuse. Okay, so 16 is the adjacent side. And then if we drew a line from theta to the opposite side of the triangle, that side is the opposite. All right, and then from SOHCAHTOA, we know that tangent is opposite over adjacent. And we have the adjacent side, but we do not have the opposite side. All right, so in order to do that, we plug these sides in to the Pythagorean theorem. So when we do that, we get the adjacent squared plus the opposite squared is equal to the hypotenuse squared. And then we plug in numbers and then solve for what's left. Okay, and then if you plug in 16 squared into a calculator, you get 256. And then 20 squared is 400. All right, and then we solve for that missing piece. So if we subtract 256 from both sides, we get 144. And then in order to undo that square, in order to undo this 2, we have to take the square root of both sides. And when we do that, what's left is just the opposite, and then the square root of 144, which is just 12. Okay, so before I actually plug this into the trig function, are there any questions about what's up here? What do you do if you have a radical in the Pythagorean theorem and it has to turn into a whole number? We're not there yet. We will get there. So just hold on. you have to take the square root of both sides because we have to cancel out this 2 right here. Okay, so the opposite squared is equal to 144, but we don't want the opposite squared. We just want the opposite side. In order to undo that squared, we have to take the square root. That square root undoes the squared. So when we do that, when we take the square root of something squared, we're just left what's on the inside. Okay, now after we get this opposite side, then we can actually get the tangent of theta. All right, and that would equal to 12 over the adjacent side, which is 16. Simplify that, and we get 3/4. Now, this doesn't just have to be the tangent of theta. It could be the tangent instead of c. Both of those would be interchangeable. Okay, because c, this angle, refers to this angle right here, which is the same as theta. Okay, before we move on to the next example, which again will slightly get harder, are there any questions about what you see up on the screen? Is there an easier way to write it out? I'm not sure exactly what you're referring to. What is it, I guess? If by it you mean the Pythagorean theorem, uh, as you do this more and more, right? So I'm showing a lot of steps right now, so you know exactly what's happening. All right. Um, as you do this more and more, you have to show less and less steps. All right. I could normally when I do this, I don't have this step right here. And I usually don't show this step right here. Okay. I'm writing out as many steps as I can so you guys can actually see what's happening. If you feel comfortable skipping some of those steps, that's okay. I do want to see a little bit of work so I know what you're actually thinking. But it's okay if you don't show every single step. All right, I'm giving you everything you see so you can actually go through the same thought process. Okay, let's move on to the next example. So 11, this is on the same worksheet. This is number 11 on that second worksheet. It's asking you to find the cosine of A given this diagram. All right, the first thing we need to do is to determine what sides we're actually talking about and what sides are what. All right, so the first thing, we should just get the hypotenuse. And the hypotenuse is always opposite the right angle, which is 3 root 2. Okay. Then we have to determine what the opposite side and adjacent sides are. So the adjacent side is always the side attached to the angle we're talking about, but is not the hypotenuse, which in this case is right here. And then if we drew a line from A to the opposite side of the triangle, we get the opposite side. So step one is to just kind of see what sides are what, right? Then we have to determine what we need. So cosine is adjacent over hypotenuse. And we're not given the adjacent side, so we need to find it. Okay, so we need to plug this into the Pythagorean theorem. Plug in what we have, and then solve for the unknown. Okay, so we don't have adjacent. All right, and when we plug in what we know and what we don't, we get this up on the screen. All right, and then we have to solve for the adjacent squared. All right, this first part, though, is easy. 3 squared is just 9. We still don't know that part yet. This 3 rad 2 squared looks a little bit intimidating, though. All right, keep in mind that this square, this exponent, tells you what you're actually doing, and you're multiplying by the thing it's attached to. You're multiplying that by itself. That's all that's saying. Okay, so we can rewrite this as 3 rad 2 times 3 rad 2. And again, this is a step that you don't necessarily have to show. I'm just showing you so you actually know what's happening. Okay, and then 3 rad 2 times 3 rad 2. In order to simplify that, you combine like terms. All right, so 3 times 3, we do that first, that's 9. And then rad 2 times rad 2 just becomes 2. And then we can solve for that adjacent squared. All right, so if we subtract 9 from both sides, first of all, 9 times 2 is 18. And then we subtract 2, or subtract 9. So we get adjacent squared is equal to 9. Take the square root of both sides. So we get that the adjacent side is equal to 3. Okay, before I move on to the actual trig ratio, are there any questions about what you see up on the screen? All right, so the next part, we just have to plug that into our trig ratio, and then we get an answer. A square root times itself will always just be a regular, yes. Yeah, so square root, so like square root of 4 times square root of 4 is just 4. Square root of 17 times square root of 17 is just 17. All right, then we have to plug those numbers into the trig ratio. So our adjacent side is 3, and our hypotenuse is 3 rad 2. Then we just have to look at our answer, though, uh, and see that that is not a rational fraction. And we have to make it a rational fraction. So we have to take 3 over 3 rad 2 and multiply it by this clever form of 1. And when we do that, we would get 3 rad 2 over 3 rad 2 times rad 2, which just becomes 3 times 2. So we get 3 rad 2 over 6. 3 divided by 6 is 1/2. So we get rad 2 over 2. Okay, again, are there any questions over anything on the screen so far? This problem is done. Are there any questions over this entire question? Why wouldn't it be 3 rad 2 over 6? Because we can simplify 3 rad 2 over 6. Three over 6 is just 1/2. And then that rad 2 just stays there. How did you get 9 from 9 times 2? So 9 times 2 is 18. And then 18 minus 9 is 9. I guess I can finish that step. We subtract 9 there, Tyler, in order to solve for our adjacent side. So we're trying to get that adjacent squared by itself. In order to do that, we have to subtract 9 first. All right, let's move on to the next example, which again is just a little bit harder, requiring slightly different tools. All right, I believe this is just directly from IXL. Okay, we're given this triangle RQS, and we're trying to find the sine of Q. Again, the first thing we should always do is to determine what side is what. So we're dealing with angle Q. So we're dealing with this angle right here. If we draw a line from this angle to the opposite side of the triangle, we get our opposite side. If we draw a line from our right angle to the opposite side of the triangle, we get our hypotenuse. And then the other side just has to be the adjacent. And we know that sine is always going to be opposite over hypotenuse. How did you make the fraction rational? I'm not going to scroll back up just yet. Let's wait until a little bit later in a problem and we can do that again. Okay. So because we have sine as opposite over a hypotenuse, we have the opposite side. We do not have the hypotenuse side. So again, we got to plug those sides into the Pythagorean theorem and then solve for the unknown. And when we plug in our numbers, we get 4 rad 2 squared plus 3 rad 6 squared is equal to the hypotenuse squared. All right, and now we have to kind of deal with radicals again. All right, so I'm going to write extra steps just so you can see what's happening. 4 rad 2 squared. Does it matter what order you put the equation in? No, it doesn't. So long as it's opposite and adjacent on one side and hypotenuse on the other. All right, so 4 rad 2 squared is 4 rad 2 times 4 rad 2. 3 rad 6 squared is 3 rad 6 times 3 rad 6. And then we still don't know the hypotenuse. Okay, when we simplify green, we need to combine like terms. So we do 4 times 4, that's 16. And then rad 2 times rad 2, that's 4. Or sorry, that's rad 4, which is just 2. Rad 2 times rad 2 is just 2. 3 rad 6 times 3 rad 6. We multiply the 3's together first, that gets 9. And then rad 6 times rad 6, that's just 6. All right, and then we can go about solving for the hypotenuse. Okay, so 32 and 54, that's 86. We have to take the square root of both sides. And then solve. All right, now, if we make a factor, if we try and simplify the square root of 86, we have to pull out perfect square factors. Now, if we make a factor tree, there's really no other factors other than 2 and 43, neither of which are perfect squares. Okay, what that means is that we can't simplify this radical. So that radical just stays as is. All right, so now that we have the hypotenuse and the opposite side, we can put it into sine of q. All right, so the opposite side is 4 rad 2. The hypotenuse is rad 86. And then again, that looks like a correct answer, but it is not rational because that has a square root in the denominator. So in order to correct that, in order to rationalize that fraction, we have to multiply by this clever form of 1. And what that does is it gets us 86 in the denominator and then 4 times rad 2 times rad 86. So rad 2 times rad 86 is rad 172. And then we can simplify. And I get that this is a longer problem, but this is kind of what this is all about. All right. So if we take 172, make a factor tree. Actually, I'm going to do it this way. If we take 2 out of 172, we get 86. Another 2, and we get 43. Okay, so we can rewrite the square root of 172 as the square root of 2, square root of 2, times the square root of 43, which is just equal to 2 rad 43. So our numerator can really be written as this. Yes. Yeah, always simplify it. Do we have to simplify the radical before we input it in the fraction? You can. Regardless, your fraction, your overall answer has to be as simple as they can get. So whether you do that before you put it into the fraction or after, that's kind of up to you. All right. But again, this problem still isn't done. So we get 8 rad 43 up top, and then 86 down bottom. If we take 2's out, get 4 rad 43 over 43. And then that, because we cannot simplify it anymore, and it is rational, it is a rational fraction, that is our answer. Okay, so for these problems, step 1, determine which side is actually what. So determine the adjacent, the opposite, and hypotenuse sides. Step 2, find what you actually need, and then solve for it using the Pythagorean theorem. And then step 3, which is where I think you guys would probably struggle the most, is to rationalize and simplify the actual ratio. Okay. Now take a second. Are there any questions about what's up on this screen? Okay, got a couple more examples. And it looks like a lot of examples. These actually go by a little bit quicker. Again, these are directly from IXL. So this problem, the center problem, is asking for the cosine of I given this triangle. Okay, so we know that cosine is adjacent over hypotenuse. And then let's determine what side is actually which. So we know the side opposite the right angle, that's the hypotenuse. And the adjacent side is the side attached to our angle, in this case I, that's not the hypotenuse. So this side is the adjacent side. So this problem looks very, very difficult because that has a bunch of square roots, and we're not really sure exactly where to go. But if you just look at what you have, especially in this fraction, you can determine that this square root of 34 over square root of 34, that cancels. So we get 9 over 18. which simplifies to 1/2. And then we're done. Questions about this problem? Okay, the next problem is kind of the same thing. Given this triangle, we need to determine what the sine of z is. So we know that sine is opposite over hypotenuse. So in order to find the opposite side, we draw a line from z, the angle that we're talking about, to the opposite side of the triangle. And that's our opposite side. The hypotenuse is the side opposite the right angle, which is 6 rad 2. Okay, and again, some things cancel very, very quickly. So this rad 2 over rad 2, those cancel. And we're left with 3 over 6, which again is just 1/2. Questions on this problem? All right. I think one more example, and then we'll go to teams. And if you have any individual questions, I can answer them there. All right. So given this triangle, again, this is directly from my Excel. All right. Given this triangle, we want to find the sine of y. So keep in mind that sine is always going to be opposite over hypotenuse. So we need those two sides. So then let's determine what sides we actually have. Right? Hypotenuse is always going to be the side opposite the right angle. The side adjacent is the side attached to y that is not the hypotenuse. So this is the adjacent side. And then if we draw a line from y to the opposite side of the triangle, that's our opposite side. Okay, so we're given the adjacent and hypotenuse, but we're not given the opposite. So we need to find the opposite. Again, by plugging that in to the Pythagorean theorem. And when we do that, we get what we have on the screen. And we need to simplify and solve for the opposite side. Okay, so 2 rad 105 squared is just 2 rad 105 times 2 rad 105. 4 rad 35 squared is 4 rad 35 times 4 rad 35. And then we still don't know the opposite. So in blue, in order to simplify this, we do 2 times 2 first. That's 4. And then we do the square roots together. So square root of 105 times square root of 105, that's just 105. 4 rad 35 times 4 rad 35. Again, we do the 4s first, that's 16. And then rad 35 times rad 35 is just 35. So 4 times 105, that's 420. And then 16 times 35. It's 560. Okay, now we just need to solve for that opposite side. So I'm going to bring this up here. So if we subtract 420 from both sides, we get 140. And then we need to take the square root of both sides. That cancels out the squared. And we have to simplify the square root of 140. All right, so when we do that, if we take out 2, we get 70. We can take out another 2, we get 35. So we can rewrite the square root of 140 as the square root of 2 times the square root of 2 times the square root of 35, which just equals 2 rad 35. And that is our opposite side. That is the simplified opposite side. So if we put that back up in our ratio, we had 2 rad 35 over 4 rad 35, which this rad 35 cancels out with the other one. So we get 2 over 4, which again is just 1/2. And then that is all the work that would be done. Okay. I realize that is a lot of work, but there are 3 things I'm expecting to be able to do. Identify parts of a triangle and use triangle trig. Use the Pythagorean theorem and deal with radicals. Okay. This problem covers a lot of that. All right. So before I end this, Are there any like general questions that I can answer right now? Why do we make 140 a square root? All right. So this step right here, originally, we have the opposite side squared is equal to 140. All right. We don't want the opposite side squared, though. We just want the opposite side. Okay, so those are side lengths. We don't want the side length squared. We just want the original side length. All right, so right here, this isn't the opposite squared. It's just the opposite. Any other questions? So I would like this IXL done today. You probably should have been able to get to 50-ish by now, 50 or 60-ish. I would like that done today. And I realize that's kind of quick. Um, but I think we should be able to do that. So you have the rest of this kind of period to work on that. All right. So I'll leave this stream open for the next like minute or so. Um, but after that, I will be in teams for questions, and I don't want 1,000 people talking the entire time. This is so I can actually honestly help people. Um, do we have to finish all of it? Yeah, you have to finish all of it. This is homework. It is R1 and IXL. Okay. So I'll leave this open for the next minute or so, and then I will start a meeting in teams. Again, my expectation in teams is that this is people who are talking or people who actually need help. How many points is the IXL worth? The same amount of points it normally is. It is due today. What time is it due? It's due today. You guys can get that done. You do not all have to go to teams. If you understand it and you can do it on your own, or if you finish it, you're fine. All right, so I will end this and I will be in a meeting in Teams in the next 30 seconds. And yes, you are finishing R1. That is your homework. All right. Thank you, and I'll see you in like a minute.